Hello students, welcome to Virtual Lab. Today we are going to see about ultrasonic interferometer. First we are going to see about the theory, then we are going to see the procedure, next we are going to see about the simulator. By using the simulator you are going to take the readings. Okay, so first we'll see the theory. In this ultrasonic interferometer, our aim is to calculate the velocity of ultrasonic sound, and the next aim is to calculate the compressibility of the given liquid. You can use any liquid, you can use water or acetone, alcohol, anything. So we are going to calculate the velocity and we are going to calculate the compressibility of the given liquid. So these are the apparatus we need: ultrasonic interferometer, the sample liquids, either it's a water or acetone, anything, and high frequency generator. So before going into that simulator, doing the experiment by simulation, we should know some basics about ultrasonic interferometer. Ultrasonic interferometer is a simple device which can produce ultrasonic sound in the liquid medium. Liquid medium, you can use any medium like water or acetone. So this will produce ultrasonic sound in the liquid medium. What is ultrasonic sound? It is a sound which is in between 20 Hz to 20 kilohertz. So, it is a sound that is 20 Hz to 20 kilohertz. It's a human audible range. But ultrasonic sound is a sound, or ultrasonic wave is a sound. Ultrasonic is a sound wave which propagates through the medium. Okay, and the range of ultrasonic is above 20 kilohertz. Okay, so the ultrasonic waves are produced by the different methods. So the main common method is a mechanical method, piezoelectrical generator, magnetostriction generator, etc. So here in this ultrasonic interferometer, ultrasonic sound can be generated by using the piezoelectric crystal. Okay, how it can be generated? As we know, what is ultrasonic sound? If the frequency range is above 20 kilohertz, then we can say it is a ultrasonic sound. And how it is can be generated? One common method is piezoelectric generator. So see, this is a piezoelectric crystal. If you apply a mechanical pressure on this piezoelectric crystal, the crystal is get vibrated. So this vibration produces the ultrasonic waves. Okay, so once again I'll tell you, this is a piezoelectric crystal. If you apply pressure on this piezoelectric crystals, this crystal will vibrate and this vibration will produce the ultrasonic sound. Okay, so this is the simple method we are going to imply in this ultrasonic interferometer. So this ultrasonic this effect we are going to imply in this ultrasonic interferometer, and we are going to produce the ultrasonic sound. After producing the sound, we are going to measure the velocity of ultrasonic and then the compressibility produced in the medium, or medium will be either liquid or acetone. Okay, so what is ultrasonic interferometer? You can see this picture. This is the ultrasonic interferometer. Okay, so here you have a micrometer, and here this is the reflector, and this is the medium. You're going to pour the medium liquid in this, either water or acetone, and this is the quartz crystal. This quartz crystal will produce the ultrasonic sound waves inside this medium, and this is the input. Okay, so this is ultrasonic interferometer. By using the micrometer, we are going to measure the wavelength and the compressibility. Okay, now we will see the formula for this. See, the formula for the velocity is lambda f. Lambda is the wavelength, f is the frequency, and the formula for the compressibility beta is equal to 1 by rho v squared. Rho is the density of the liquid, v squared is the velocity of the liquid. So from this velocity, if we find the velocity here, we can, if you substitute here, we can find the compressibility of the adiabatic compressibility of the liquid. Okay, now let us see the simulator. So this shows the simulator. Here we are going to take the readings. Now first we have all the either acetone, kerosene, castor oil, glycerin. Now I'm going to take water. Okay, now frequency I'm fixing as 2, and here this adjustment I'm adjusting this. After this we have to power on. Next, adjust this. I'm adjusting this to 60 adjustment, and gain I'm adjusting 50. Now I'm just rotating this micrometer using this arrow marks. Okay, now see, reflection takes place in this, okay, ultrasonic interferometer. See here, you have to measure 2 reflections. Okay, one reflection is over. See, another reflection is happening here. So to and fro motion. Okay, to and oscillation. Okay, so you have to see 2 oscillation. Now I have recorded 2 oscillation. Okay, so this is how the what we are used, the medium we used water, and here you can see the reflector plate. This will produce the piezoelectric. Due to this piezoelectric effect, it will produce the ultrasonic waves. Okay, now show graph, show result. Now see the result. Velocity of ultrasonic wave is 1480 meter, and adiabatic compressibility is 4.5 into 10 power minus 10. So you have to measure here what is the micrometer reading. Okay, now here see, micrometer reading is 40. This is 1 and this is 45. So you can write the result, velocity of ultrasonic waves and adiabatic compressibility, directly. Okay, so again, once again I'll show you. Now I'm fixing the wavelength as 3. Okay, now I'm just rotating this, I'm just resetting, I'm fixing this frequency as 3. Now power on. Now adjustment is, I'm just keeping this adjustment as 80, and gain I'm just keeping as 50. Now see the oscillation, one oscillation is over, second oscillation is over. Okay, now show results. So see, the velocity of ultrasonic wave is 1480 meter per second, and the compressibility is 4.58 into 10 power minus 10 meters squared by Newton. So this is how we have to calculate the velocity and compressibility using the simulator. Okay, thank you.